Hey guys, Chapter 5, Section 6 video here for you if you are using the book we're using in class. And our essential question today is how can I organize my work in a table? So we're going to start looking at some problems where a table can be helpful to get us started. And last night when I was cooking, I kind of got inspired to make this lesson. So I'm going to show you why here in a minute. But some important things to write down first. Rate. Rate is a word that means speed. So if I tell you I'm driving in my car 30 miles per hour, that's my speed. That's how fast I'm going, but that's also my rate. It's also another way of saying your growth number. So when you're looking at a growth in a pattern, that's another way of talking about rate. So I'm always telling students, don't forget that rate and speed and growth and even slope are all kind of in the same category. They're just different ways of saying the same thing. And the inspiration that I had last night when I was cooking is we were making rice. So we're going to make an example about that. Have you ever cooked this minute rice before? It's super easy. It's not very good rice, but it's quick and easy if you need to make dinner fast. It cooks in like 5 minutes, I think, tops. And the recipe is super simple. It just takes the water and the rice from the box, basically. And I was reading the back of the box and I looked at the directions and it made me think of this. So here's what the back of the box looked like. On the back of the box to cook the rice, there was a table and it said servings, rice measured in cups, and water measured in cups. So this is what we're going to put in our notes today. Could you copy this table into your notebook, please? What we're going to do is we're going to look at what's going on in this table. And the table has servings at the top, which is probably the most important thing to pay attention to. There's 2 servings, 4 servings, and 6 servings. 2 servings means you want to feed 2 people. 4 servings means you want to feed 4 people, and 6 servings would mean you want to feed 6 people. So when you go to cook dinner, like I have a family of 4, I would be looking at the 4 servings column and I'd be like, oh, I need 2 cups rice and 2 cups water. Or if I was like, oh man, my family is super hungry. I only have 4 people, but I'm going to make 6 servings so we have extra food. Well, then I knew if I did 6 servings, I know I need 3 cups of rice and 3 cups of water, and I throw it in the pot and start boiling it up. So this is my quick go-to chart to know how much rice and water that I need. Well, we're going to talk about what the unit rate is. The unit rate is when you have a 1 in the denominator. So if you have 1 cup of rice for 1 cup of water, that is your unit rate. That means it takes 1 cup of rice for 1 cup of water to serve 2 people. And what we're going to do is we're going to plot this interesting table onto our graph here. And on our graph, we're not going to need any negative numbers. We only need positive numbers. There's no negative rice, no negative water. So we're going to set up an XY axis that says rice and water. And we'll number it, get some scale numbers on there. 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, 6, 7. I got up to 10, and that was enough room. And we're going to take the servings and plot them on the graph. What I mean by that is if it's 1 cup rice and 1 cup water, I'm going to go to 1 rice and 1 water and place a point. If it's 2 cups water and 2 cups rice, I'm going to do the same thing. 2 cups rice, 2 cups water, place a point. If there's 3 cups of rice and 3 cups of water, I'm going to go to 3, 3. And what happens is we get this graph with these 3 points that we can grab a ruler and we can connect. Now, I hope you're using a ruler to set up your graph, and I hope you're being very neat and organized. I'm going to guess that you probably have to pause the video a couple times just to catch up with this and like make it nice. Because if your graph is truly done neatly, you're going to be able to answer this question. And the question is this a proportional relationship? So to be a proportion, you have to have 3 things. Is it proportional? Well, let's go through those 3 things. First, the graph needs to be a line. I think we got that. It is for sure a line. Like I said, if you were neat and organized in your graphing, you should have got a line too. So check, we got a line. Second thing we're looking for is, does the line pass through the origin? Does it go through 0, 0? And I'm circling 0, 0, and I'm noticing my line hits right at 0, 0, and yours should too. So check, passes through 0, 0. Now the last piece. The last piece is if we made two fractions, are they equal to each other? A proportion is two equal ratios. So if I made a fraction of 1 over 1 and 2 over 2, are those the same thing? Well, divide it. What's 1 divided by 1? And what's 2 divided by 2? That'd just be 1 and 1. Check. Yeah, y over x is equal to y over x. We have equal fractions. All three things pass, which means yes, this is a proportional relationship. The answer is yes, it's a proportion. And look how nice and neat my work is. I know I kind of overanalyzed the back of this box of rice that I was cooking last night, but really look at everything. It's labeled, the graph paper's nice and neat with the plotted points. I know I'm doing it on a computer screen, but on your graph paper with your paper and pencil, you should have a nice, neat setup like mine. All right, so we're going to try another problem. We're going to get away from the rice example and try something else. Let's talk about painting. Have you ever had to paint your house before? Maybe help paint your bedroom or the outside of your house? It's kind of a lot of work painting. So when you go to buy paint at the store, they often mix colors together to make the color that you want. So our story is about mixing 3 pints of yellow paint for every 4 pints of blue paint. And if you mix yellow and blue, you get green. And we're going to paint our house green. So we're going to take this story and we're going to build a table. In our table, we've got the yellow paint and the blue paint. So we're going to say yellow measured in pints and blue measured in pints. And the ratio to get that perfect green is 3 to 4. 3 yellow and 4 blue. They mix it all together. They put it in that shaker machine at the store and get you that perfect green color that you want. But if you needed to double the recipe, if you were like, well, I need more paint, then you'd have 6 pints of yellow and 8 pints of blue. If you did that again, you could have 9 and 12. And if you did that again, you could have 12 and 16. Going up by 3s and up by 4s in kind of a pattern here. Because if we didn't go in a pattern, then when you go to the store, if you were to change it and mix different numbers of pints, you wouldn't get that perfect green that you want. You'd get something else. Well, we're going to graph this table. And again, I don't see any negative numbers. We're not going to have negative yellow paint or negative blue paint. So we're going to do all positives. Grab a ruler, make it really nice and neat on your graph paper. Label that x-axis as our yellow paint and the y can be our blue paint. And then let's number this thing. We're going to put a scale on. I think we can go just 1 to 10. Oh, wait, can we go 1 to 10? Look at the numbers in the table. Goes all the way up to 12 and 16. Shoot, we're going to need more space. I don't think 1, 2, 3, 4, 5 is going to get me up to 12 and 16 very easily, unless I want to make a really big graph in my notebook. And I don't. So let's take that away. How about we go by 2s? What if we went 2, 4, 6, 8, 10, 12, 14? Then we can get all the way up to those big numbers. I'll do the same thing on the y-axis. 2, 4, 6, 8, 10, 12, 14, all the way up to 20. That way we have enough space and we don't have to make a huge graph in our notebook. And now we plot our points. So we're going to put the 3, 4 on there first. 3 yellow, well 3 would be right between the 2 and the 4. And then 4 blue, so I'm going to put a point right there. And then we're going to plot 6, 8. So we go 6 yellow and up to 8 blue. And then we're going to do 9, 12. That means 9 would have to be in the middle of 8 and 10. And then up to 12. And then we're going to do 12 and 16. 12 and all the way up to 16. And if we're being nice and neat, we should be able to connect our points. It looks like a nice line again. So we should be able to answer this question, is this a proportional relationship? So let's go through it. Is this a proportional relationship? Well, is it a line? Yeah, it's totally a line. We can see that, so check. Does it go through the origin at 0, 0? Mine does. If your graph is nice and neat, I'm hoping yours does too. So yeah, I'm going to say check, passes through 0, 0. And then the last and final question, equal fractions. Could we make equal fractions out of 2 points in the table? Would 4 over 3 be the same as 8 over 6? So to answer this question, we could simplify the fractions, or we could just divide them. We could grab a calculator and do 4 divided by 3, 8 divided by 6. Go ahead and type that in your calculator. Are they equal decimals? 4 divided by 3 is 1.3 repeated. 8 divided by 6 is also 1.3 repeated. Sweet, so that's a check. They are matching, so y over x equals y over x. all three things are true. We checked off our boxes here, so the answer is yes, it's a proportion. All right, you guys, so last example for our notes is about a store that is selling printers and computers. And the store is keeping track of how well they're doing for sales. And they come up with this conclusion that for every 2 printers that they sell 5 computers. What I want you to do is I want you to see if you can make a table and a graph out of this story. Go ahead and hit the pause button on your device and see if you can do this problem. Alright, so you've given this a try, you're unpausing the video, you've made a table and a graph, I hope, and we're going to see if you did it correctly. So in your table, we've got printers and computers. They sell 2 printers for every 5 computers. So the pattern has to be a 2/5 ratio, meaning the next would be 4 and 10, 6 and 15, 8 and 20. Now there's no negative numbers, so the graph is again a first quadrant graph. We're going to label it printers and computers. I'm going to number my graph and scale it out. On the x-axis, I went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That seemed to work. But for computers, look at the table. We got to get up to 20 computers. So I'm going to go by 2s to get up to 20. 2, 4, 6, 8, 10, all the way up to 20. And then we're going to plot our points. So 2 and 5 means 2 printers and 5 computers. That'd be between 4 and 6. 4 and 10, that means 4 printers and 10 computers. 6 and 15 means 6 printers and 15 computers. And then 8 and 20 is our last one, so 8 printers and all the way up to 20. And you grab a ruler and you draw your line, and you start asking yourself, is this a proportional relationship? Do we have all 3 qualifications? Is it a line? Absolutely, that kind of stood out right away. Does it go through 0, 0? Does it hit that origin spot? Totally goes through 0, 0. If you were nice and neat and you used your ruler, it should have gone through 0, 0. And then the last question, will the fractions be equal to each other? This one doesn't always hold true, so let's check it. Is 5 over 2 equal to 10 over 4? Well, divide it in your calculator. 5 divided by 2 and 10 divided by 4. What decimal do you get? And I got 2.5 and 2.5. So the answer is yes, check. Those fractions are equal. Y over x equals y over x, which means yes, this is another proportional relationship. This is a proportion. So you guys, the summary for this video is you're kind of looking for 3 things. Is it a line? Does it pass through 0, 0? And are there 2 equal fractions? And if all of those are true, you've got a proportional relationship. Thanks for watching, guys. I'll see you in the next video.